Computational modeling, dynamic quantum model approach. Alexander Weissblut, Kherson State University. Motivation. The contradiction in science. The structural stability of a mathematical model, its equivalence invariance under small perturbations, is necessary condition for its correctness. After Smale's works, it became clear that dynamics of the system of general form is not structurally stable. Therefore, there is no strict mathematical basis for modeling and computational analysis. The contradiction appeared in science. According to physicists, dynamics is simple and universal. Dynamic quantum model. The solution to this problem was proposed by the author based on the construction of dynamic quantum models. DQM is abbreviation. DQM is a perturbation of a smooth dynamical system by a Markov cascade given by the transition function P of YA. Time here is distinct. If mu of t is the distribution at time t, delta t is the lag, then the DQM sets mu distribution at time t plus delta t, P of mu at t, is equal to mu sub t plus delta t. Taking into account random fluctuations allow us to return to the simple picture of Poincaré dynamics, a dense set of structurally stable systems. We can prove this proposition. The paper goal to build the foundations of the theory of dynamic quantum models, DQM, to demonstrate the application of this theory for spectral problems of quantum mechanics. DQM for Hamiltonian systems. DQM is simply related to the Schrödinger equation. There is a simple correspondence between DQM Markov cascades P of A and quasi-solutions of the corresponding Schrödinger equation. The quasi-solution is simply solution in accuracy of h squared. Thus, DQM is a bridge between the formal calculus of quantum mechanics and the intuitive version of physicists. The spectrum of Schrödinger equation and DQM. In DQM, spectral problems are reduced to the usual perturbation theory of smooth dynamical systems. Thus, the construction of such models can be considered as a method for solving spectral problems. This paper gives an example of such approach to the one-dimensional Schrödinger equation with the quasiperiodic potential u of x equals cosinus x plus epsilon multiplied by cosinus lambda x. Here is epsilon and lambda parameters. The spectrum of Schrödinger equation with quasiperiodic potential. First, the point spectrum is distinct if lambda is rational. If lambda is irrational, then the point spectrum with increasing epsilon expands to segments around the eigenvalues at epsilon equals 0. That is, here is initial eigenvalues at epsilon equals 0, and then with increasing epsilon, this spectrum expands to segments around the eigenvalues, and at epsilon equals h, it occupies the entire region. for order epsilon of order 1 over h, with increasing of epsilon, the point spectrum converging to some district points. DQM in general forms its discretization. DQM is defined for any dynamical system given on any smooth Riemannian manifold. As a Markov cascade, any DQM is approximated by a Markov chain and on compact set by a finite Markov chain arbitrarily exactly. This allows you to build effective algorithms for the study of dynamical systems, and in this way, the structural stability of the commands leads to mathematically grounded numerical analysis. On the other hand, the symbolic dynamics of Markov chains, which is equivalent to neural network dynamics, leads to new applications. For example, for dynamical systems that using logical operations, algorithms, software applications, theorems. Fuzzy logic in DQM. So let G equals G of Z be a given smooth function on phase space, equal to 1 on the trajectory of the original smooth system and 0 outside some neighborhood of it. We can interpret it as the function of Trott. In this paper, DQM is defined and constructed universally for both Hamiltonian systems and systems with a Trott function G. DQM spectral in general form. Physically, a point in the spectrum is the value of Hamiltonian H, energy in the phase space on the trajectory, obtained as a result of the most accurate experiment. Taking into account the removable errors and discreteness of the measurement process and its limited time, we arrive at the maximum number n sub t of the most accurate measurements of this formula. Similarly, at h equals g, that is, when we use the function of Trott, the point of the DQM spectrum is interpreted exactly as the average value of the Trott for approximate logical conclusions. Spectrum quantization for DQM with fuzzy logic. Consider the two-dimensional dynamical system, the compact space of which is filled with closed phase curves. If we interpret G as function of Trott, then at semantic level we are talking about transition on loops or two equivalent propositions. Proposition: the DQM eigenvalues are equal to the values of G of Z on the phase curves which satisfies the Bohr-Sommerfeld condition. This is Bohr-Sommerfeld condition and only they. So we can get this classical proposition even for situation where we use the G, the function of Trott. Equivalence of structural stability and hyperbolicity. On the other hand, when fluctuations tend to zero, i.e. in the semi-classical limit, DQM goes into the initial smooth dynamics. In this way, the old problem of equivalence of structural stability and hyperbolicity for smooth discrete dynamical systems was established. And we get this in this two form, this fact. Proposition 1. A diffeomorphism on a compact manifold is structurally stable if and only if it is non-uniformly hyperbolic, And proposition 2, suppose that sufficient proximity of a given diffeomorphism to an arbitrary one implies their topological equivalence. Then this given diffeomorphism is uniformly hyperbolic. If we use the Tratt function G, we get the opposite example. We take the situation with dQm solvability. dQm d sub epsilon of system with logical operations are all uniformly limited by the number of operations for any epsilon fluctuations. Then for them solvability is not in doubt. The same is true for the union D of sets d sub epsilon over all small fluctuations. D is union of d sub epsilon k. However, as a rule, this is not true for semi-classical limit of d epsilon, i.e. for the classical logical systems. And then, can the union D be considered as the solvable model for the original real systems? As for me, I think yes. And conclusions. The structural stability of a mathematical model is a necessary condition for its correctness, but after Smale's works, it became clear that in smooth dynamics, the system of a general form is not structurally stable, and therefore there is no strict mathematical basis for modeling on computational analysis of systems. The contradiction appeared in science, according to physical dynamics, is simple and universal. The solution to this problem was proposed based on the construction of dynamic and quantum models, DQM. From the assumption that quantum effects are caused by unrecoverable white noise, a certain mathematical model of quantum mechanics already follows and is essentially unambiguous. This model is simply connected with the traditional one. Construction of such models can be considered as an asymptotic method for solving spectral problems, for example, for the one-dimensional systems with quasiperiodic potential. But the definition of DQM is not formally related to Hamiltonian systems. It is defined for any ordinary differential equations or any diffeomorphisms on any smooth Riemannian manifold. DQM is defined and constructed universally for both Hamiltonian systems and systems with a true function. As a result, for example, the point of DQM spectrum is interpreted exactly as the average value of Tratt from approximate logical conclusions. Or quantization is also extends to systems with a Tratt function, and Bohr-Sommerfeld condition is also preserved. On the other hand, when fluctuations tend to zero, i.e. in the semi-classical limit, the dynamics of the DQM goes into the initial smooth dynamics. The equivalence of structural stability and hyperbolicity for smooth discrete dynamical systems is established along this path. However, as a rule, semi-classical limit of solvable DQM is not a solvable classical logical systems. Thank you for your attention.